Today I want to talk to you guys about oil changes and transfusions. So let's go on a journey. It's a beautiful day outside, you're driving your brand new car, and then you hear a beep. You look down and you look at the oil symbol. It's lit up. Now to get this checked, you go to a technician. The technician pulls out your oil stick and looks for the oil quality and quantity. If either of these are concerning, then they do an oil top up, which is just a replenishment of the oil. Usually, this fixes the problem and you're well on your way. 80 to 90% of premature infants are commonly admitted into the neonatal intensive care unit because of their physiological state. In monitoring these infants, a common occurrence is anemia. Now, anemia is the reduction of functional red blood cells that carry oxygen to your tissues. It is diagnosed via a protein known as hemoglobin. Hemoglobin is found in your blood. So to diagnose this protein, you need to do a blood draw. If the levels of hemoglobin are concerning, then you perform something known as a red blood cell top-up or a transfusion. Now, the inherent problem in this population is that they don't produce their own red blood cells for the first 3 months of life. This means every time we diagnose them, we're actually taking out storage of the red blood cells, which starts the cycle of drawing blood and having to give them blood. But what if I told you there was a better way? Now, in the car, there was an alert to us that made us go to get it checked out. But in babies, we don't have that alert system. Now, babies in the NICU are commonly monitored at the bedside. Indices such as heart rate, respiratory rate, blood oxygenation are all monitored. What if I told you there was a way we could use this information? My thesis focuses on exploring the relationships between heart rate variability and anemia at the bedside using an artificial intelligence solution known as Artemis. Artemis can take physiological streaming data from these bedside monitors, process, analyze it, and store it in real time. This means that I can take that heart rate information that is currently not being used, I can put it into a heart rate variability algorithm that looks at the beat-to-beat difference between each heart rate. If this algorithm detects a concerning trend, then it can create an alert for the physician. This is massive. This means that I can reduce the amount of blood draws, I can reduce the resultant transfusions, but most importantly, I can better patient outcomes for our tiniest human beings. With the power of AI, we can now make patient-centered decisions. So just remember, the next time you go for an oil change, you're basically giving your car a transfusion. Thank you very much.